Hello, welcome. This is now question 6 for Edexcel's M1 June 2003 paper. Now this particular question is quite a difficult one, purely because we're now throwing this pebble, particle or whatever it is, at this slope of an incline of 30 degrees. Now bear in mind, we're not considering that it's going to go like that. We're considering that the person is actually below Earth and throwing it up through Earth with no negative consequences of being starved of oxygen and likely to have died. No, we're not bothered about that. All we're bothered about is this maths problem. Okay, now the reason it's a little bit weirder than what it normally is because what we'd normally do in this situation, if this wasn't the case, what would we do? And as I said, this is not for this question. If we weren't throwing it and we were just saying, okay, well, work out the reaction force or the acceleration of this block, what we do is, okay, well, we've got mg cos theta, as I've written on here, is the reaction force, so therefore that's the reaction force as well, off the plane, and F equals UR is acting up the plane, and mg sine theta is acting down the plane. And then you would take away the two parallel forces, because obviously it's not sinking into the plane, which would give us a resultant force which we'd use, divide by the mass to get the acceleration, and we'd be away. However, this is obviously not what we're supposed to do, because we've got this u as 6 meters per second. Now initially this doesn't have much of an impact, because what we need to do is the frictional force acting on P as it moves up the plane. As I said, this first is not necessarily that difficult, but I'm going to answer it a bit later on when I've introduced all the parts of this question, okay? So if you're just interested in the part A, please do skip a few minutes because I just want to go over this, okay? Right, now we said F equals U, right, okay, so the reaction force on the plane doesn't change, okay? So we've still got mg cos theta out the plane and acting into the plane. And we call that the reaction force as normal. Okay, but because our initial speed, now we're moving up this way, okay, so we're moving up the plane, we always know that our resistance force, F equals UR, which is what this is asking us to find out, always acts in the resistance force always acts in the opposite direction to motion. The reason we normally draw it acting up the plane is because generally when you put something on the plane, it wants to go down it, okay, because obviously there's a bigger force pulling it down towards the centre of the Earth, obviously. So that's why we have F equals UR acting up the plane, but because we're pushing it up the plane and there's a motion pushing it up the plane, therefore the resistance force must be acting in the opposite way. It must be acting going down the plane. So therefore we have to point the F equals UR acting down the plane. But our mg sine theta also acts. That hasn't changed, okay? That's just the way it acts due to our working it out, okay? So mg sine theta still is acting down the plane. That hasn't changed, it hasn't been affected. It's just this F equals UR business, okay? Now don't get this confused, F equals mu r. It's key, the reason they've done this is because they've told you an initial speed of 6 meters per second, and that's u. And now you would naturally assume, if you weren't concentrating, F equals UR is 6 meters per second times the reaction force, which clearly isn't the case, because when you were working out other questions like this, you didn't have an initial speed, and you would have assumed quite clearly, incorrectly, that u is the coefficient of friction, which it is. But really, for part A, they've just left that in there to kind of confuse you and make some people think, well, that's associated with u, and I know the frictional force, F equals UR, and we'll put u as being 6 meters per second, which, as I said, you don't do, because the u is actually the coefficient of friction. It's not the initial speed, okay? So that's something to go off straight away. Okay, so F equals UR, R being this mg cos theta, so just sub in like we always do, okay? And we told you, sorry, the coefficient between the plane and the incline is 0.4, sorry, I should have told you that. So that's mu, alright? So mu r, so therefore it's 0.4 times reaction force, which is mg cos theta, the mass is 3 kilograms, so I'm just going to go ahead and write this in, so 3 times 9.8 times cos of 30, because we're told the incline is of 30 degrees, okay? So make sure your calculators in degrees, okay? So that would get you 10.2 newtons, Okay, I think it's actually 10.18, but we round it up to 10.2 because we can. Okay, so the next part is distance moved by p up the plane before it comes to an instantaneous rest. Okay, now obviously what we need to do for this is work out the acceleration. Now obviously we're going to have, because our initial speed is 6 meters per second, we want to, this is now a SUVAT equation mixed with inclined planes. Okay, so what we want to do is we want to work out the distance moved by p until it stops. So obviously we want the distance, s. We've got the initial speed, u, remember this is the initial speed, of 6 meters per second, okay. We've got the resistance force, this is not the resultant force, the resistance force, okay, is equal to 10.2 newtons or 10.18 newtons. We've got our, we don't know our acceleration, okay. Okay, it's not 9.8 because we're not dropping it in free fall. Okay, so we don't know our acceleration, or in case it will be deceleration, but we just leave it as A, okay? And that's all we really can work out from this. Now there's no point putting in the other factors such as T, because, well, there's no point working out because it's not asking the time to stop, okay? It might be useful, I might be able to use that in a SUVAT equation, but really it is quite pointless. So we're going to ignore T, that's all we need. Now, obviously we've got two unknowns in there, so we can't use s equals ut plus a half at squared or anything like that, because we don't know A and we don't know S, okay? Because S is what we're trying to find out. So as we've got two unknowns, there must be another way to find A, okay? Now, as I was talking about before, we can normally work out the resultant force along the plane, and that is equal to mass times acceleration, or it will be deceleration, okay? So let's go ahead and just work out the value for A, okay? So as we said, what we'd normally do is mg sine theta take F equals UR, okay? But because they're acting in the same direction, obviously we're going to take them away from each other, okay? So it's going to be minus 10.2 newtons, because it's acting in the opposite way it would normally, take mg sine theta, okay? And that is equal to the mass times the acceleration, okay? So we're still doing what we know, minus 10.2 newtons, which is F equals UR. And the reason we've done minus on both of them is because we will end up with a, what we want to do is we want to end up with a negative resultant force, because that means we'll have a negative acceleration. Don't get confused, don't get worried about the fact that we're having a negative resultant force. And how can we possibly have a negative resultant force? That's because the resultant force is going in the opposite direction to the motion is going. That's why we'll end up with a negative. And there's no point doing mg sine theta take 10.2 newtons, because, well, they're both acting in the same direction, so we wouldn't want to know the difference between them two, because, as I said, they're acting in the same direction. We want a negative resultant force, because, well, we know it's a negative resultant force, because what we've got here is the force acting in the opposite direction to the motion. Now there's no force, it's not being continually pushed up this plane, it's just been pushed up to 6 meters per second and then just let go, and it's continued to go on until it's going to stop. Okay, so there's no actual force pushing it up, so we can't take, there's no difference that we have to work out. There's all the forces are just acting down the plane at the moment. Obviously it will come to a rest, and then if it starts to move back down the plane, which it will do after it stops, but we're not considering that bit, then the F equals UR would move to the other side, okay? But as I said, for this moment, we're just considering the fact that both forces are acting down the plane as this ball's moving up, so we will have a negative resultant force. As I said, the forces are acting in the opposite direction to motion, and they're both acting in the same way, so we just make them negative, okay? So hopefully that's explained why we've got this weird business going on here. Okay, so it's minus 10.2 newtons take m, which is 3 kilograms times 9.8 times the sine of 30 is equal to the mass times acceleration, or 3 kilograms times A. Okay, obviously that A is going to be negative because we want that to bring it to a stop from 6 meters per second. Okay, so you work all that out, divide it all by 3, so therefore we get A is equal to negative 10.2 newtons take this 3 kilograms times 9.8 times sine 30. And I said that's all over 3, okay? So if you sub that in your calculator, get a value for A, which is negative 8.3 metres per second squared. So it's good, it's deceleration, that's what we want. Okay, so you can sub that in, therefore, now to your value of A, which is negative 8.3 metres per second squared. Okay, so what I'm going to do now is just rub this, working up. So I'll just give you a second if you want to copy this down. What we're going to do now is just apply a SUVAT equation to this. Oh no, I'm not going to rub it out. I do apologise because we've not got another part. This is the last part of this question, so I can just sub it in over here. Okay, so we're going to continue this over in this little corner. Okay, now we've got all the other values. We've got U, we've got the resistance force. Actually, the resistance force isn't part of the SUVAT equation. I do apologise. So you can kind of ignore this resistance force now. We've worked it. We've used it. So we've got S, U, A, and we want to work out S. Okay. Oh, sorry. We also know, obviously, if it's going to come to a stop, the final speed is going to be 0 meters per second. I do apologise, missed that out. So the equation that links V, A, U and S together, or whatever, which way you want to say it, is V squared equals U squared plus 2AS. Now obviously, because A is negative, it's going to be V squared equals U squared take 2AS, but we're just going to leave it as that until we put in our numbers. Okay, so you don't get confused. V squared, well, obviously, is going to be 0 squared. It's equal to U squared, which is 6 squared, I'm just going to put 36, plus 2 times negative 8.3 meters per second squared times S, which is the distance, which is what we want to work out. So therefore 36 is equal to 2 times 8.3 times S. Okay, so therefore you rearrange that to get S on its own in meters, and you should get an answer of 2.17 meters. Okay, and that is your final answer for question 6. Okay, so that's question 6. Hopefully I've explained it in some varying degree of acceptable detail. But as I said, if you want me to go over it again, because maybe I've gone over it too fast, as I said, I'm trying to get through these M1 papers, so wasting my life and yours, although this is the way I want to spend it, which is quite sad. Anyway, so thanks for watching, and we'll see you in the next video, which hopefully should be question 7.